All right, we're going to be graphing points in the polar coordinate system. And then in the next section, well, this is 6.4, but in the next section, 6.5, we'll actually be graphing some polar equations as well. I'm just going to do a quick lead into what we're talking about here. Just going to graph a simple point like 2, comma 2. If I were to ask you to graph a point 2, 2 in our rectangular coordinate system or the Cartesian coordinate system, immediately you think, I got to go 2 to the right and 2 up, because XY tells us what our horizontal movement is and what our vertical movement is. So you go right 2, you'd go up 2, you'd have that point, and that would be it. We're going to talk about what that point would be in the polar coordinate system. The polar coordinate system gives things in terms of r and theta. So theta would be the angle that this point is on, that this terminal point is on. So theta in this case, if you're at 2, 2, we know that theta then would be 45 degrees or pi over 4. R would be what the distance is from the origin here, which we're going to actually call the pole in our polar coordinate system. From the origin to that point, that distance would be called r. Well, if the point is 2, 2, think about how we could find what that distance is. That distance would just be using the Pythagorean theorem, x squared plus y squared, would be 4 plus 4. Actually, it's 2, sorry. 2 squared plus 2 squared would be 8. So the square root of 8 would be 2 squared to 2. That would be the length of that side of that triangle there, which is basically just using the Pythagorean theorem or almost the same thing as the magnitude of our vectors that we just talked about in the last section. It'd be like magnitude, the length of that, if this were a vector right here, okay? So this would be, these 2 points represent the exact same point. So this would be in the rectangular coordinate system, or the Cartesian, it's also known as, and this would be in the polar coordinate system. Okay, so let's talk a little bit more about that polar coordinate system. So take a second to get this stuff kind of all down here, and we'll talk about the difference between if r is positive or if r is negative. All right, if r is a positive value, then when we open up our angle theta, like I have shown in this picture right here, when we open up theta, we would just put our point r units away from the pole, which is like the origin, on that terminal side. If r is negative, though, and that's what this picture is showing down here, then we would open up whatever our angle is, we would open up that amount, but then we would put the point on the other side of the pole, that amount. So if r were negative, now we'd go back and we would put we'd put the point P on this side and say that this must be r units then from there to there. If r is negative, then we would go back to the other side. Okay, let's see that in action right here. So the first example there, we're going to graph 2 comma pi over 3. The easiest thing to get first from everything that we've done with trigonometry and vectors is an angle of pi over 3 would be right there. I'm just going to put that that's pi over 3. So we know that the point is somewhere on that line. Now we just need to scale out our axes here. So I'm going to go by halves and make this 1, and then this 2, and then this 3. So why we use a circular graph like this is it's easy to find distances along any terminal side. So if I want to go out 2 units on that purple line, I know that it would be right there, that's where point P would be. Let's do example C next here. We have an angle of negative 45 degrees, and that would put us right here. There's our negative 45. And we want to go out 3 units on that terminal side because r is positive. So we've got, I always like to number this axis here, we've got, I'm going to go again 1, 2, and 3 here. So 3 units out on that would be right there. So this would be point R, because we're calling that R this time. All right, the second example there, example B, notice we have a negative R value. So the first thing we're going to do is open up 3 pi over 4. 3 pi over 4 has a reference angle pi over 4 in the second quadrant, so here is 3 pi over 4 right here. But because r is negative, what I want to do is extend this so I can picture that that angle going all the way through. And because r is negative, we want to plot it on the other side here. So I'm going to go with the same scale. So this is 1, 2, and 3 right here. So if it were a positive one, I would put Q right there. I'd be on the terminal side if it were a positive one. So if that negative wasn't there, that's where point Q would be. But since it's a negative, I want to put it on the other side of that terminal side, which is really the terminal side plus pi. That's where Q is going to end up being right there. So we open up 3 pi over 4, but then we put it on the other side, plot the point on the other side of the angle. And other side isn't very technical. It's just an easy way, I think, to remember. It's on your terminal side plus pi. Okay, it's as if your angle was reflected over that pole. Okay, now the next, that example two there, that whole section, we're actually going to cover in the second video and on the second day of class. I think it makes the most sense to actually go to this next page here and talk about our polar and rectangular conversions. So take a second to get all these formulas down that you have right here, or that I have written here, and then we'll talk about what each of them mean. All right, these formulas should remind you a lot of what we did with vectors, especially these two guys right here when it comes to our component forms of our vectors. So you don't have to write this stuff down, but I just want to remind you, we wrote our vectors a comma b in component form, and we wanted to write a vector in component form. If we were given the magnitude and the angle, we would take the magnitude of the vector and multiply it by the cosine of our angle. We would take the magnitude of the vector and multiply it by the sine of the angle. In other words, the horizontal component of our vector a equaled the magnitude times the cosine of v. Well, that's exactly what that's saying right there. X equals the r value, which is the distance from the pole to the point. That's just like the magnitude. It's the distance, the length, times the cosine of theta. And b would be equal to that r value times the sine of theta, just like magnitude times the sine of theta. And then this r equals stuff, this is just like the magnitude. How we said the magnitude is equal to the square root of a squared plus b squared. This stuff is saying the same thing, just in terms of r, x, and y. And then obviously we had our formulas for theta using inverse tangent, cosine, or sine. And we had, back with vectors, we used a over magnitude, we'd use b over the magnitude, or we use tangent and just do b over a. Same ideas, just different variables, different parameters here. So we are going to use these things to help convert from polar to rectangular and vice versa. So first we're going to go from a polar to a rectangular coordinate here. So this is a polar coordinate. We're going to do a quick little sketch of this guy here. So 5 pi over 6 is what I'm going to graph first. I know an angle of 5 pi over 6 looks like that. And then I'm just going to put that, we know that r is 3, so if that's our point P, then this must be a distance of 3 right there, just to have a little sketch of what it looks like. So in order to find out what this looks like as a Cartesian or a rectangular coordinate, we are going to say that our x value is going to equal r times the cosine of our angle theta. Basically what we're doing is we're taking the unit circle value, which would have a magnitude of 1 or an r value of 1, and multiplying it by 3 so that it has an r value of 3. So this would be, well, we'll come back to that in a second. Let's write down how we'd find y. Y would be 3 times the sine of 5 pi over 6. So as you're doing these, don't forget whether you should be dealing with a positive or negative value. We're in the second quadrant, so cosine is going to be negative. And the cosine of its reference angle, pi over 6, is square root of 3 over 2. So the cosine of 5 pi over 6 is negative square root of 3 over 2. Our y value is going to be 3 times, let's see, sine is positive in that second quadrant, so we're going to have a y value of 3/2. So the polar coordinates of this thing are negative 3 squares of 3 over 2, comma, 3 halves. And we're going to leave these as exact fractions since we didn't need to use our calculator to find that. In the next one down here, we are going to definitely need our calculator because we don't have a nice reference angle. Our reference angle here is negative 200 degrees. So just to get an idea here, negative 200 degrees we know would be in the second quadrant. And we now have, let's see, there's our point Q, and we know that this is a length of 2 right there. So we're in the second quadrant again, so we're negative positive. So we have that x equals 2 times the cosine of negative 200, and that is going to end up being about negative 1.88. Make sure your calculator is in degrees, please. And y is going to equal 2 times the sine of negative 200. And that's going to give you about 0.68. So that would be our point in rectangular form in its Cartesian coordinate form, negative 1.88, comma, 0.68. All right. All right, in our next couple of examples here, we're going to be going in the other direction. We're going to be taking some rectangular coordinate points. So this is an x comma y point, and we're going to be putting it into the form r comma theta. So that's what we want our final answer to be. Our answer is going to be, just as a reminder, because it's kind of new to us, r comma theta. Okay, so we need to find out now. Some of these points that we're going to be given, we actually could use a little bit of what we remember from trigonometry to help us figure out what the angles are. We won't need all the formulas and everything. Think about where negative 1 comma 1 is. Just going to do a quick sketch here. Negative 1 comma 1 is in the second quadrant. Okay, think about what the standard form angle would be to get to that point right there. Negative 1 comma 1 would be on the angle 3 pi over 4 because the reference angle is pi over 4. So we know in the second quadrant 3 pi over 4 is our theta value. Now what we need to know is what this r value is here, that distance from the pole or the origin. If you're in the rectangular, what is the distance from the origin to that point? So we know that we can find that distance by taking the square root of a squared plus b squared, or I'm sorry, back in vectors, x squared plus y squared. So we've got the square root of 1 plus 1. So r is just going to be the square root of 2. So we know that the radius here is a square root of 2, and our theta is 3 pi over 4. So that is going to be 1 point, because if you notice here it says find 2 polar coordinate pairs. So that's 1. It doesn't come out and say this, but what I'd like you to do is try to find one that has a positive r value. So one's going to have a positive, I don't want to do a there, that's our example. So one is going to be a positive r value, and the second one, so I'll call it little 1 and 2, is going to be a negative r value. So this is our answer, our first answer right there. Our second answer is going to be a negative r value. So it's got to be that same distance, so it's got to be square root of 2, but this time we're going to make it negative. So what angle would we have to use right there? Well, let's move some of this stuff out of the way here a little bit. The angle that we'd have to use is, if we had a negative r value, would have to be an angle that opens up to this terminal side right there. And then making it negative would put the point back on this side here. So we have two options here. We can either make this a negative acute angle, or we can find this angle going all the way around to right there. I'm just going to use the negative acute angle here and call it negative pi over 4. So this would be our second point here. Not sure why I switched colors there. Our second point, we'll just make this all green, would be negative square root of 2, comma, negative pi over 4. So Okay, let's just make sure that that makes sense. Think about if I asked you to plot that in the polar coordinate system. The negative pi over 4 means I'd open down to here. The negative r value means that I'd have to plot it on the back side of it at a distance of square root of 2 away from the pole. So that is the exact same point that we talked about before. All right, this next one here, this is, remember, this is a xy coordinate point here, and we want r comma theta. So negative 3, 0, we're just going to do a quick plot of that. It just looks like this. All right, so this can be a pretty easy one to come up with here. Let's think about what this would be as first a positive r value. Well, this angle right here is 0. It's 0 radians. So with an angle of 0, hold on. I'm glad I caught this now. You guys probably were like right away, what the heck's he doing? Negative 3 comma 0 is over here. There we go. There's negative 3, 0. There's Q right there. Okay, so let's try this again. So this angle that opens up that has Q on its terminal side is pi. That would be the positive angle there. And then the distance that that point is away from the pole is 3. Notice that I don't put negative 3 there. Okay? That is a distance of 3 away from the pole on the terminal side of an angle pi. All right, so now our second angle with a negative r value, our negative r value would mean that we need the angle to actually be on, open up with the terminal side here, and then have a negative r value of negative 3. So what I would need then is not to have my angle open up at all. I need my angle to be 0 radians. Because if I do 0 radians, and then I have a negative r value, a negative 3, that'll put me on the back side, which would be over there. So we have negative 3 comma 0, but don't confuse this. These are not the same. All right, these are not the same. This is an x comma y point. This is still r comma theta. This guy right here, this is r and this is theta. So maybe to help us remember that, we could add in this little, this is 0 radians right there. We're going to open up 0 radians and then plot it on the back side of that angle, or pi away from that angle, 3 units away from the pole, which would give me that same point Q. Okay, now we're going to move into the next piece of this section here, which are equation conversions. And actually, you know what? I'm going to start a new video for that. We're going to do this and then some of the stuff that we have left to finish in the front. So we're going to do that in our next video.